Today we shall discuss about collisions in oblique projectile. Okay, in a simple and shortcut method, see, when two bodies are projected with certain different angles, they are going to meet at certain height, at certain place, and after certain time, they are going to collide with each other on the in their path. Okay, so we shall discuss about that here now. So let us observe. There is one particle which is thrown with an angle of 53 degrees, and there is another particle which is thrown at an angle of 45 degrees. Then this as well as this, they will collide at certain point here now. So let us imagine this is a point of collision. Okay, so this is moving in this direction, this is moving in this direction. They both collide at this place now. They are going to collide at this place. So what is the condition for the collision here? You just observe one thing. When their vertical velocities, vertical component of velocities are same, then only they are going to collide. Let us imagine this is having more velocity, this is having less vertical component, then definitely they are going to miss like this. So when this is more and this is less, they are going to miss like this. When this is more and this is less, they are going to miss like this. They don't collide. They escape from each other. So for collision to take place, their vertical component of velocity should be same. Then only they will collide. So we need to find out the place where they are going to collide, and also we can find out the time also. Let us see what happens now. Let us imagine this is the first particle here. This is the second particle here. Okay. So when you project them with an angle of 45 degrees and 53 degrees with different angles, they are going to meet at certain points and they are going to collide at that point. We need to find out after what time they are going to collide. But I told you that when they move in a different angles, their vertical component of velocity should be same for collision to take place. Their vertical component of velocity should be same for collision to take place. If the vertical component of velocities are different, for example, left side body is having more velocity compared to the right side, then they won't collide. They escape from each other. The first one will move with higher speeds, so they will escape from each other. So that's what I am telling here. So the condition which you need to remember is their vertical component should be same for collision to take place. That is the clue here. If you understand this, then it is very easy. So let us see. Find u. You have been throwing this second particle and this is the first particle with certain angles, so 53 and 45 degrees. You need to find out what is the velocity of the second particle so that they will collide at this place. And the distance between these two is considered to be 70 meters. They are 70 meters away from each other and they are colliding like this. So previously, let us consider both are at these particular points 1 and 2. Then let us see what is going to happen. I told you for collision to take place, vertical components should be same. For collision to take place, their vertical component should be same so that they exactly meet each other. Okay, so that is the condition here. So let us see what is going to happen now. Here, if you observe, the vertical component is 50 sine 53 degrees is equal to, and this velocity as we don't know, we can write sine 45 degrees here. Okay, so you know the value of sine 53 degrees. Sine 53 degrees is nothing but 4 by 5, and this is u sine 45 is nothing but u by root 3. So this is 1 times moves, it's 40. So u, this is u, and this is 4. Okay, so this is 4. So 4 into 10 is 40 here. So u will become, this 4 into 10 is 40. This root 2 comes to this side, it becomes 40 root 2. 40 root 2 meters per second. So we got the velocity of the second body, that is 40 root 2 meters per second. So once you find out the vertical component, it is very easy to find out the time now. Okay, so we got u. then how are you going to find out the time of meeting, time of collision from the point of projection? Because both the particles have been thrown at same time. They will meet after some time here. Okay, we need to find out the time also. To find out the time here, it is very easy. Okay, so how can you find out the time here? For example, this is 53 degrees and this is 45 degrees here. We need to consider their horizontal components. We need to find out their horizontal components. You know, horizontal component of the second body is u cos 45 degrees, and the first one is u cos 53 degrees. This is moving in this direction and this is moving in the opposite direction. So we need to add them. So what is the relative velocity here? So relative velocity of both the particles is considered to be u cos 53 degrees minus of, relative velocity means minus of minus u cos 45 degrees here. Okay, and this you already know it is 50, so you can write here 50, and this u also you got now 40 root 2, so you can also replace that with 40 root 2. Okay, so 40 root 2 you can replace here, 40 root 2 you are writing here. So let us see what is going to happen now. So here v relative is nothing but 50 into cos 53 degrees. So cos 53 degrees is nothing but, it is 3 by 5. Minus of minus will become plus here. So 40 root 2 into cos 45 is again 1 by root 2. So root 2 gets cancelled here. This is 10. So relative velocity is going to become 30 plus 40, which is equal to 70 meters per second. Okay, so we got the relative velocities in the x-axis. On the x-axis we got the relative velocities, because if you find out the velocities along the x-axis, that is the relative velocities along the x-axis, then we can find out the time also. Okay, so time we can find out like that. Time is equal to distance by relative velocities. Distance by relative velocities. Distance is nothing but 70 meters and relative velocity is also 70. So your answer is going to be 1 second. The meaning here is both the particles will meet after 1 second. That is the case here. So let us do the similar type of problem here. That is problem number B. So here with an angle of 45 degrees, we are projecting the first body. Okay, and we are projecting the second body with an angle of 37 degrees here. Okay, so this is 37 degrees and this is going to be 45 degrees, and this is projected with a velocity of 30 root 2, and we don't know what is the velocity, but we know that they are going to collide at certain point here. Okay, so they are going to collide at this place. It is coming from this side and this is coming from this side, that's left and right, and they both are colliding at this point. Now let us consider this is the point of collision. Let us imagine like that. As I said before, collision to take place, their vertical component should be same, then only they will meet. Their vertical component should be same, then only they will meet, they will collide with each other. If vertical components are different, then they cannot collide with each other. There will be a lot of difference in their speeds. So speeds, vertical component of velocity should be same, then only they will collide. Okay, let us see here also. The same method you are going to apply here also, and let us find out the answer here. So same step you can write here also. For collision to take place, their vertical component should be same. So therefore we can write 30 root 2 sine 45 is equal to u sine 37, u sine 37 degrees here. Okay, so this is sine 45 root 2, both get cancelled because sine 45 is 1 by root 2. This is 30 and 5. So you can write opposite side by hypotenuse 3 by 5 here. Okay, so after that you'll be getting how much? U is equal to 30 into 5 by 3. Therefore this is 10. Be getting u as 50 meters per second. So we got the value of u, that is 50 meters per second now. So this is already known to you how much it is. This is going to be 30 root 2 meters per second. This is going to be 30 root 2 meters per second. So let us find out now where they are going, after what time they are going to meet. Find the time when they collide. Same thing you will write now. Same thing you will do. Time is equal to distance by their relative velocities. Distance, you know, 70. Relative velocities is nothing but in this direction you need to find out this component here, and in this direction you need to find out the component here. So first of all, you can find out the relative velocities. So relative velocities, how can you find out here? This is going to be 30 root 2 cos 45 minus of minus in this direction. This is going to be that is minus 50 cos 37 degrees, and this is going to be 30 root 2 cos 45 degrees. Okay, so this is coming in the opposite direction. You can consider it to be minus here. So minus of minus cos 37 degrees here. Okay, so after that, what are you going to do now? Relative velocities you will find out now. 30 root 2 and these two gets cancelled. What is left now? 30 is left. So minus of minus will become plus here. And this is 50. And you know cos 37. So how much is cos 37? This is 37, 53, 3, 4, 5. Cos 37 is 4 by 5. So you can write 4 by 5 here. So 5 ones, 5 tens here. So V relative is going to be 30 plus 40 here also. It is going to be 70 meters per second. Therefore, time is equal to distance by relative velocities. Here also 70 by 70. So they are going to meet exactly after 1 second. Okay. So this is a method of solving the problem regarding collisions. Okay.